Welcome to Galileo STEM. This is topic 3.2 of the AP Calculus curriculum, so if your mind's ready to function, let's dive into some implicit differentiation. Well, first off, what does that even mean? Well, to know that, we have to figure out the difference between explicit and implicit functions. In an explicit function, y can be isolated on one side of the equation as a direct expression of x. An example of this would be a function like y equals 3x plus 2. On the other hand, inside of an implicit function, y simply fails to do this. The function is just too complicated. An example of this would be something like xy cubed plus y squared equals 36. It's just too complicated. Now I get that somebody really smart might be able to solve this, but on the AP exam, we don't got time for that. So before we find the derivative of these implicit functions, let's review by finding the derivative of explicit functions. Here we have y equals 6x squared plus 5x minus 3. First, we'll start off by using the power rule on 6x squared, where the exponent of 2 multiplies by the x while also subtracting by 1. This gives us a result of 12x. And you know what the derivative of 5x is. It's 5. Oh yeah, and the derivative of whole numbers, as you know, is 0. This should give us a final answer of 12x plus 5. And now that we're done reviewing, let's move on to an implicit function. As you can see, we have xy cubed plus x to the fourth minus 5 equals 8y plus 2. A mouthful, I know. And I bet you're wondering, how the heck am I supposed to solve this in terms of y? Well, that's the thing, you're not. It's an implicit function. So, let's get deriving. First, we'll start off by using the product rule on xy cubed, which will give us x times 3y squared plus 1 times y cubed. Now, wait a second, did you notice what I just wrote? Next to every y term that you differentiate in an implicit function, you must put the term dy over dx. This happens because when you're differentiating with x, it's x with respect to x, which cancels out. But with y, it's y with respect to x, which doesn't cancel out, leaving you with this term. This is important because inside of implicit functions, you need to solve for the derivative, which means solving for dy over dx. So to do that, you must isolate it in these implicit equations. So returning to the problem, the derivative of x to the fourth is 4x to the third. And here it happens again. The derivative of 8y is equal to 8 dy over dx. This is because we're working with another y term. And then obviously 5 and 2 will just go to 0. Okay, so putting this all together will give us x times 3y squared times dy dx plus y cubed, also plus 4x cubed, equals 8 times dy dx. What we need to do next is isolate all of the dy dx terms on one side of the equation and leave all the other terms on the other side of the equation. After this, you can factor out the dy dx from both terms so you can completely isolate the derivative. Now all there is left to do is to divide by both sides, and boom, you've officially found the derivative of an implicit function. However, this is only one example, so if you want to crush your AP exam, then you're going to need to know how to solve for the derivative of many different types of these implicit functions. Anyways, I really appreciate you guys for watching, and I would also appreciate it if you guys subscribe to help me make you more videos. I'll see you in the next one.